Good day everyone. Today we are going to discuss the household income management system for our computer programming group assignment. Our last session is 1H and we are group 3. Now, let me introduce myself and my group members. My name is Lim Jia-Chi and I'm the group leader. My group members are Lim Jia-Xuan, Ko San-Si, Tei Fu-Nian, Chong Kai-Jing, and Kang Xuan-Xing. Here is our table of contents.
Hi everyone, now I'll be introducing the Household Income Management System. These interactive tools make it easy to manage and analyze household incomes data. It allows users to categorize incomes into B40, M40, and T20 groups, sort them in ascending and descending orders, and also calculate key details like totals, average, maximums, and minimums incomes. With input validations, it ensures accuracies and provides a user-friendly experience. Next, the system's main objectives are to simplify navigations, ensure accurate data collections, identify household needing assistance, and also offer versatile tools for effective income analysis.
Thank you, Jia-Xuan. Now it is the time for exploring our system. First, we tell the compiler to include the IOStream center header file and use IOStream in a standard way. Now, I will pass the presentation to San-Si to explain the variable declaration.
Thank you, Jia-Chi. So now we need to do the function declarations. A void function does not return a value. A string function returns the value of type string to the caller, which is main functions. Void greeting is a function to display greeting message. Void get income is a function to get household income. String category is a function to determine household income classifications. Void classification is a function to display household income classifications. For the void ascending and descending, it's a function to arrange and display household income in ascending and descending order. For void income min and income max, it's a function to identify and display the minimum and maximum household income. Then its void total is a function to calculate and display the total household income. Finally, its void average is a function to calculate and display the average household income.
Thank you, San-Si. In main function, we declare manual option and number of household as integer variables and ans as character variables. Greeting is used to call the greeting function. And greeting message is now displayed. After that, user is asked to enter household number and user input will store into num of household variable. We use while loop to handle error. Where user enters 0 or negative numbers, the invalid message will be displayed and ask user to enter again. Cout line is used to print a new line. An array income num of household is declared and initialized to store the household income data. The getIncome function is then called. The argument income array is passed as the parameter listing array to store the household income data, and the argument num of household is passed as the parameter num, specifying the number of household entered by the user. This function uses for loop to collect household income data. A counter variable I is declared and initialized to 0, and the loop continues the iteration as long as I is less than num, which is the number of households entered by the users. For each iteration, the system asks the user to enter income for household I plus 1. We use I plus 1 instead of I to display user-friendly numbering starting from 1. The user's input is then stored in the array at index I. After storing the input, I is incremented by 1 to move to the next household. For example, when num is 5, which is 5 households, the first iteration will store user input, which is 3,800 ringgit and 50 cents in array listing at index 0. And the second iteration will store user input in array listing at index 1. This process continues until the 5th iteration. For the 6th iteration, I is equal to 5. So the condition I less than 5 becomes false, and the loop exits. The do-while loop allows the users to repeatedly perform various household income operations until they decide to exit. The block inside the do is executed at least once. Inside the do-while loop, a menu with 7 operations is displayed for user to choose from by entering a number between 1 and 7. User input is then stored into the option variable, and the corresponding function will be executed. Now, I will pass the presentation to Fu-Nian.
Thank you, Jia-Chi. And now I'm going to discuss the function to determine the income category. As you can see, the string IM class is to declare IM class as string variables to store the income categories such as invalid, B40, M40, and T20 based on the input household's income. We are using an if-else statement to classify the input household's income. If income, which household's income of user input is less than 0, and it will be classified as invalid. Once the part of invalid was done, as you can see, we write else if income is less than or equals to 5,250 and greater than or equals to 0, the double symbol you can see is called AND, and it will be classified as B40. Third, else if income is less than or equals to 11,819 and greater than or equals to 5,250.1, and it will be classified as M40. And last, we write else and write return IM class equals to T20 on the line below the else. That means if income is greater than 11,819 is classified as T20. Actually, the if statement is linked to the case 1, so let me proceed. The slide begins with the switch option statements, which is used to handle different menu selections based on the user inputs. In this program, the value of options determines which case to execute. For case 1, the program calls the classifications functions, passing two arguments, income and array containing households income data, and number of households, the total number of households in the array. After the function is executed, the break statement ensures the program exits the switch block, preventing further case from being executed. After that, above for loop, this is the same things as Jiaqi discussed already. We look at below the line of cout. Actually, in the output, the expressions I plus 1 dynamically generates the household number. For the explanations, Jiaqi was discussed already also. Last, the classifications of each household's income is determined by the category brackets functions, which is called with the current household's income and the listing square bracket I as its arguments. Right now, let me discuss the output. As you can see, this is the output of classifications. When the household income 1 is RM 3800.50, the classifications of household income is B40, and the household income 2 is classified as M40. The household income 3 is classified as B40. The household income 4 is classified as T20, and the household income 5 is classified as B40. Last, as you can see, the user input of household income 6 is RM negative 1000. When the user insert the value below 0, the classifications will be displayed invalid. So these are the things that you need to be known. So that's all for me. So now I'm going to pass the mic to Sensing.
Thanks, Onion, for explaining the case 1. In case 2, we will arrange and display household incomes in ascending order using a switch case. A pointer is passed to the function, and when passing a pointer in the sorting function, it behaves the same as passing an array, because the pointer references the memory location of the array elements. This similarity allows us to manipulate the array or any block of memory referenced by the pointer directly inside the function. To sort the elements in the income array, we employ the bubble sort algorithm, which arranges the element in ascending order. And now I will explain how the bubble sort function works using a simple example, which is an array of size 5 in its worst case configuration. For an array with 5 elements, a maximum of array size -1, in this case, 4 rounds is required to complete the sorting process. During each round, the number of comparisons needed decreases as the largest unsorted element is placed in its correct position at the end of the array. The number of comparisons in each round is calculated as array size minus current round minus 1. In the first round, where outer loop I equal to 0, the 0th element 5 is compared with the first element 4. Since 5 is greater than 4, their positions are swapped. And next, the update first element 5 is compared with the second element 3. And once again, 5 is greater than 3, and thus their positions are swapped. This process continues for the third and fourth comparison, with the largest value 5 being moved to the last position in the array. In the subsequent rounds, the number of comparisons decreases by 1 with each iteration, as the largest unsorted elements are successively placed in their correct positions at the end of the array. For instance, in the second round, where I equal to 1, comparisons are only performed on the first 4 elements because the last element is already sorted. Through this process, the bubble sort algorithm is able to reduce the number of unsorted elements in the array, and ensure that the entire array is sorted in ascending order by the end of the final round. This slide will show the second part of the ascending function definition. From the print screen, we can observe that the household income values are sorted and displayed in ascending order using the bubble sort algorithm. Besides, if a user enters income values with more than 2 decimal places, the output will automatically round off to 2 decimal points, ensuring a smooth and uniform display. Now I will let Kaichi proceed with case 3.
Thank you, Shenxing. Now let's look at the third case. The function uses selection sort instead of bubble sort. We can achieve the descending order by using selection sort and putting the biggest element in front of the array one by one. We start with a loop that iterates array size -1 times through the array elements, which means the last index is not iterated. This loop will use alphabet I as index. Here, we create a pointer to a double named biggest, and assign it with the address of listing I first for the later comparisons. Then we start another loop. It will iterate from the index I plus 1 to the last element in the array. In the loop, if listing J is bigger than the element pointed by biggest, then biggest will point to listing J, making it the current biggest element. When this loop ends, biggest pointer will be pointing to the biggest element that is after index I. Now we swap listing I with the element pointed by biggest pointer. First, we save the value of listing I temporarily in TMP. The value in listing I will then be replaced by the biggest value. Finally, the value of element biggest will be replaced by TMP. This whole thing will repeat for array size -1 times until it is sorted in the descending order. And same as previous functions, we call setFIOS fixed and precision2 to tell the output to round to 2 decimal places. Then we iterate and print all the elements in the sorted array. After user input, choosing case tree will sort the given household incomes and display them in descending order, as shown in the screenshot here.
Thank you, Kaijin, for explaining case 3. I will now explain how to determine the minimum and maximum income in case 4 and case 5. So in case 4, first we need to sort an array in ascending order. And Shenxing had explained just now, we can use the bubble sort algorithm, which rearrange the element from smallest to largest. For example, if the original array is 5, 4, 3, 2, 1, after sorting it becomes 1, 2, 3, 4, 5. When we have an array of size 5, indices are 0, 1, 2, 3, 4. From the slide, we can clearly see that the minimum income is found at index 0, which holds the smaller value in the array. To format the output, we use ls fixed to display number in fixed notations. We enable ls show points to ensure the decimal point is always shown, and set the precision to 2 decimal places using CR precision 2. Therefore, from the output screen, we can see that when the user enters 4, the minimum household income is displaying the smaller value with exactly 2 decimal places. If a user entering 2040.602, the output will only show 2040.60. Then, in case 5, the maximum income, the step is similar to case 4. We need to sort the array again in ascending order to get 1, 2, 3, 4, 5. In the array of size n, the last element is at index n-1. Since our array size is 5, so the last index will be 5 minus 1 equal to 4. Therefore, the maximum income is the element at index 4, which holds the largest value in the array. Same like in case 4, we use ls fixed for fixed point notations. We set our s show point to display the decimal point and limit the precision to 2 decimal places using CR precision 2. Lastly, from the output of print screen, when the user enters 5 for the choice, the maximum household income is displayed as the largest value in the array with 2 decimal places. Now, I will pass to Jiaxuan.
Now, let's look at the switch case 6. When users select option 6, the total functions with the argument incomes and num of household is called. This function is used to calculate the total household incomes. The parameter listing is an array of household incomes and num is the number of household. First, a variable total is initialized to 0 to store the cumulative sums of incomes. Then, a for loop is used to calculate the total by using equations total plus equals listing I, which is equivalent to total equals total plus listing I. And then you can see that there is an comments. Configure the output to display 2 decimal places from lines 3 to 6 to line 3 to 8. In this slide shows how a for loop calculates the total household income step by step. On the bottom left, it shows the program store 5 household incomes. The loop starts with I equals to 0. The first income is 2040 ringgit and 60 cents, which is also listing 0. It is added to the variable totals that has been initialized to 0. Now, the total becomes 0 plus 2040 and 60 cents and equals to 2040 and 60 cents. Then, the loops move to I equals to 1 and now the total becomes 2040 and 60 cents plus 3850 cents equals to 5841 ringgit and 10 cents. This process repeats for all incomes until the loop ends where variable I is less than number of household. As a result, the final total is 31412.54 and is formatted to 2 decimal places. Then, we'll move on to switch case 7 to calculate average of household income. As usual, when option 7 is selected, the average functions with argument incomes and num of household is called. The average functions is just similar to the total functions. The only difference is an equation's average equals total over num need to be added after the loop to calculate average. From the equations, the average is initialized to 0 at the beginning of the functions, and the total is the total of household income, and the num is the number of household. Lastly, the output of average household income is 6,282 ringgit and 51 cents, which is set to 2 decimal places.
Thank you, Jiaxuan. Default is used to handle the error for the option that is not between 1 and 7. Hence, if user enter 8, the invalid message will be displayed. After executing the selected operation, the system asks the user whether they want to continue. By using ans equal to 2 lower ans, the user's input of uppercase or lowercase letter y or n is converted to lowercase format to handle case insensitivity. If the user enters y, The loop starts again and the menu will be displayed for users to enter their choice. If the user enters N, the loop terminates and the system ends. That's all for our household income management system. Here is our reference. Thank you for watching.